would like to show you how to find a solution for a recurrence relation. There are many methods, but we will start with the methods by iteration. So by iteration, we will iterate over the recurrence relation by finding some of the terms, and we'll try to guess the solution from these terms. So we will solve the first question. It is already on the slide. So we will just show you how these steps are obtained. So the steps are already on the slide, but you need to understand how we have obtained these steps. So our first example number 1. Okay. Is finding a solution for this recurrence relation. So by iteration, when we say iteration, it means we go over the recurrence relation by some terms, and this method that we are going to study now, it's called forward chaining. So we are going to study forward chaining by an iteration. There is another method which is backward chaining, which is called back substitution. We start from the end. So when we say forward, it means we start from the beginning of the recurrence relation, from the initial value and up. And when we say back substitution, we start from n and we go back n minus 1 until we reach the initial condition. So by forward chaining, we need to find some of the elements. So A1 is equal to A0 plus 2. And how did we find this? We found it from here. If n is 1, then this will be 0. And A0 is the initial value, so you don't do any further simplification. Now for the next term, which is A2. Now A2 from this relation, A2 is equal to A1 plus 2. Now the value of A1 is already found from previous step. So substitute it here. So what you will get, this will be equal to, now all of this equation should be replacing A1. So this will be equal to A0 plus 2. And don't forget, we already have 2 in here. So this 2 is coming from the previous step. And now we have another 2. So we will add it into here. Don't try to do any further simplification here. Don't try to find the calculation. Don't write 4. Maybe for this particular example, it is easy to guess the pattern for the coming terms. But there are some recurrence relations. If you find the final answer, then you will not be able to discover the pattern, okay, of the recurrence relation. Just leave it now. Let's go for more. So let's go for A3. And from the recurrence relation, A3 is equal to A2 plus 2. So we have A2 plus 2. And we have already found A2 from the previous step. So this equation is for A2. So you need to replace A2 by the previous example, previous substitution. So A2, this is A2. This is A2, okay? So substitute it. So it will be equal to A0 plus 2 plus 2. And don't forget, you already have 2 from this step. Again, don't find the answer as equal to 6. Just leave it as it is. So for the next one, this is a 3. For A4, it's equal to A3 plus 2. A3, you have already found it in a previous step. So this is A3. So substitute it here. And this is going to be equal to A0 plus 2 plus 2 plus 2 and plus 2, the one that is coming from here. Maybe you can keep going that way and try to relate each element with its corresponding equation. So A1, you have A0 plus 2. Now A2, you have A0 plus 2 plus 2. So it looks like you are adding 2 twice. So this 2 tells me that I need to add 2 twice. This 3 is telling me that I need to add 2 3 times. 4, it means 4 times. So here we can guess a solution. We can say that if instead of 1, 2, 3, and 4, we put n, then how we can guess the solution on the right hand side? all of the solutions we have on the right hand side, they begin with A0. So you put A0, and then here we have 4 2's. Here we have 3 2's. And here we have 2 2's. So if I have n, so how many 2 we are going to have? We are going to have k2. So the answer for this one will be 2 plus 2, and the number of 2 is here is k times. So an is equal to a0 plus 2n. Did I say k? It should be n. By mistake I put k, and it should be n, not equal. So here we should have n. Because this is repeated n times, here it is repeated 4 times, 3 times, so here it's repeated n times, so the answer, and this is the solution for the recurrence relation.